Okay guys, I'm back to show you how to solve these two practice problems from the PowerPoint. Hopefully you didn't have any trouble with them and you got the answers that were given, but I'll give you a quick little overview of how I solved. So for practice problem number 1, which is up on the screen right now, you probably noticed those fractions and probably panicked right away because you saw fractions, but there really is no need to panic. If you notice, if I look at reaction A, the aluminum, there's 2 aluminum, and the Al2O3 is on the product side, the 2 aluminum's on the reactant side, and that matches with the overall reaction that's given in bold. So I don't need to change that one. So that one's going to stay the same. But if I look at B, B has the 2 irons on the reactant side, but they should be on the product side. So right away I say, okay, I have to write the reverse of that. So I'm going to reverse B. So B becomes Fe2O3 and then 2Fe plus 3/2 O2. Now, because I did that, I have to change the sign of this. So my new delta H is 842.2 kilojoules. So now if I look to see what I can cancel, I have 3/2, whoops, I'm not using that reaction. Let me just cross that out because we're not using that one. We reversed it. I have 3/2 O2 on the reactant side and 3/2 O2 on the product side, so I can get rid of that. And that's the only thing I can get rid of. If I look at the overall reaction now, I have my 2Al and my Fe2O3 on the reactant side, and then my products, I have Al2O3 and 2Fe on the product side. So all I need to do now is add the 2 delta H's that I was given, so negative 1,669.8 kilojoules plus 842.2 kilojoules gives me my answer of negative 845.6 kilojoules, like so. Okay, so that is practice problem 1. So now we're going to look at practice problem 2 on the next slide. Now practice problem 2, don't panic. Again, there's 3 reactions that you have to look at, but if you take it step by step and you look at what you have to get to for your overall reaction, it should all work out. So let's look at equation A. Equation A has OF2, but if you look at the overall reaction, I need to have 2 OF2. So what I'm going to do is I'm going to multiply through a 2 like so. All the way, and then that's going to become a 4. Okay, so I'm going to do that. And then I need to multiply the delta H by 2, so that becomes negative 553.2 kilojoules. If I look at the next reaction has SF4 on the reactant side, but if I look at the overall reaction, SF4 is a product. So I need to reverse that reaction. So if I reverse that reaction, I'm going to make delta H positive, so let's just do that right away. And I need to reverse this reaction. So I'm going to rewrite B down here, and I'm going to cross this off so that we don't get confused. So I have 4HF plus SO2 yields SF4. And don't worry if you're not writing things in the same order as me. As long as you have the reactants on the reactant side and the products on the product side, it doesn't matter what order they're in on those sides. So B is now rewritten. And let's look at the last reaction in C. I have S plus O2 yields SO2. I noticed that the sulfur has a coefficient of 2 in the overall reaction. I noticed though that SO2 only has a coefficient of 1, and that's already a 1. However, I have an SO2 that's in reaction B, so hopefully that will work itself out and I'll end up with 1 SO2 as a product. But I definitely have to multiply through by 2. So if I do that, that's going to put coefficients in front of everything. So I'm just going to do that. And then I have to multiply my delta H by 2, so I'm just going to cross that out, and that becomes a negative 593.8 kilojoules. All right. So let's see what we have here and what we can get rid of. I'm not going to rewrite the overall reaction. I'm just going to start canceling what I need to and keep what I don't. I have 2OF. I need to keep that. The 2S, that's going to stay. Now, I have 2O2 as a reactant here and 2O2 as a product here. So I can cancel those out. So we'll get rid of those. Here I have 4HF on a product and 4HF as a reactant, so let's get rid of those. And that makes sense to get rid of those because that's not anywhere in the overall reaction. Here I have an SO2, and here I have 2 SO2s. So I can get rid of this one, and I can cross off that 2 and be left with 1, and that makes sense because I have 1 in the overall reaction as a product. The SF4, there's nothing to get rid of that, and I need that anyway. And I have 2 H2Os as a product here, 2 H2Os as a reactant here, so I can cross those off, and water is nowhere in that reaction either. So if I rewrite this, let me just change colors so it doesn't get all crazy on the slide here. I have 2OF plus 2S yields SF4, and I forgot to box that one out, plus SO2. And that is my overall reaction. So I did everything correctly, and all I need to do now is add my delta H's together, and when I do that, I get negative 319.5 kilojoules, which is the same answer I had over here. Okay, so that is practice problem 2. So hopefully that makes sense to you. Once you have these problems checked and you feel comfortable with the work, you can move on to working on the Hess's law practice problems. That is going to be graded, so I'm going to look for correct answers there. So please show me all your work, and that's going to be your last assignment for the week. Also, don't forget to hand in any corrections on the last test that you took, so that I can get those graded over Easter break and get those in the grade book for you. So that's it for this PowerPoint. I hope that was helpful, and if you have questions, please email or ask in the forum. Talk to you soon, guys. Bye.